Hi and welcome to the WinCC OA 103. In this video I will show you how you can connect to a device, for instance via OPC UA, and to browse the device, and how to structure your data, for instance in a plant view or plant data like UNS, how to store your data, and afterwards how you can publish the data, for instance via MQTT. Let me show you. Now I will show you how you can connect to a device. In WinCC OA we can connect to the OT layer southbound or to the IT layer northbound. We have several drivers which provide this. I will show you an example now for connecting to an OPC UA server, which is southbound direction. The steps, what we need for that is we need a driver manager, we need a connection, and we need an address to say which item of the server we like to read. Let me show you in detail. First of all, we have to stop the simulation driver. Just open your console, double click the simulation driver, change the start mode to manual, say OK, and stop him with right click, stop manager. Yes. After you did so, just append a manager to your console with the icon on the right. Managers are processes in WinCC OA which can be, for instance, user interface, which can be business logic, which can be a connection northbound, southbound. We will need now a manager as a driver manager to connect southbound to our OPC UA server device. Let's scroll down in the list and pick the OPC UA Client. You can start many instances of those managers in your project between 1 and 255. Therefore, they need to have a unique number. Let's assign the number 1 minus num1 and say OK. After you started your OPC UA client, we need a connection now to the server device. For that, go back to your Getty tool and open from the system management the OPC UA client settings. The system management is the icon on top, which looks like the wheel. Just open it. Here you can find the driver OPC, and here you can find OPC UA client. First we need a new device connection. Let's create a new one. Let's call it OPC UA _server and say OK. You have to put the URL to the OPC UA server device. Basically, that is an OPC TCP address with the server hostname or the IP address and the port. I connect to this OPC UA server. You have to activate the server connection and press apply. After you press apply, you can see we are already connected and the server is running. It shows me the state here. Now I can already browse the server. You can see when I open the browse dialog, I can see my plant, area 1, line 1, pump 1, and there are certain values of pump 1. Let's map this to my data object, which I already created in the previously WinCC OA 102. Okay, this is the final step. Let's open the para, and we need a configuration for that. You remember, we created the pumps here Here's our pump 1. Let me show it with the pump 1 as an example. We have a value. Let's maybe pick the flow rate. And for that, we need now a configuration. To add a configuration, just do a simple right click, insert config, periphery address config. And just stand on the address config. On the address config, you just select the driver type, which is in this case an OPC UA Client, and you configure. Make sure that the driver number you assigned in the console is the driver number here correctly. We will use our device, what we created in the system management, and we need a subscription and an item for that. First, I want to get an item. So therefore I just pick area, line 1, pump 1, and the flow rate. Okay. Automatically I get the namespace for the flow rate, inserted as an item address here. To see now the data in WinCC OA, I just need a subscription and a direction. Let me show you. First we need to do a subscription. Let's create it as a data subscription. Okay. And let's activate our data subscription. And let's say okay. I want to read the data with my subscription. When you choose subscription, the data is automatically called as unsolicited. Finally, we need to activate the address and say OK. On the original value, I can see now the value data coming from my OPC UA server. The driver with the number 1, which is my OPC UA client, provides now the data from my OPC UA server. For the other pumps, I proceed in the same way. So I inserted now the address configs as well to the power, to the speed, and to the efficiency, and to the other pumps. There is a fast way to deploy those configs. It's called master data point. The master data point is a quick engineering tool in your Para for deploying those configuration to all your instances. I will show you maybe later in one of those other videos. You can also do an export of your data from the Para and do a mass engineering inside of an ASCII file, for instance with Microsoft Excel. Also that I will show you in one of those later videos. When you check the address, I would also suggest you later to enable the old new comparison, even if you use an unsolicited communication, because then our driver compares the data before he sends the data into our WinCC OA. That reduces load of your system. So choose old new comparison for all your addresses. Now you could see in a very few steps how we can connect to a device. Very easy. Now I will show you how you can structure your data to use it in a plant model way or in a unified namespace way, that we can provide our data northbound to some MES or IT systems which would connect to our data. For that we have a tool called Plant Model. You can find an editor for that in the Getty with the icon Plant Model Editor. Just open that. Here you can create a so-called view. This view represents your plant structure, or if you use UNS and unified namespace, also that can be designed according to your structure in your plant. To create a new view, just do a right click, create view. To give you a quick example, maybe we call it My Plant 1. The same name I like to use as the view name. Copy to all and OK. With that, I have a view called My Plant. Now I need some nodes in my plant. Let's create with right click another node. Let's call this node Area 1. The display name should be as well Area 1. In the display name you can use special characters, blanks and spaces. For the node ID name, you can see which characters are not allowed. Let's create another node in here. Let's call this node, for instance, line 1. The same I like to use here again as display name. All and OK. Under line 1, I would like to have a final node for my pump 1. Therefore, I will call this one here pump 1. The same name again I use as a display name. For the pump 1, I would like to assign now here some elements of my pump 1 data object. Remember, we created the data object pump 1 with the tags state, value and alerts. Let me create now here sub nodes and link those tags to those nodes. Therefore, I will create another node under pump 1, which I call now flow rate. With the same as a display name. Another node with a power. Again, the same display name. Another node with a speed. And one more for the efficiency of my pump. Now I link the tags of my data object pump1 to those nodes which I created in my plant model view. This you do only with drag and drop. Let's take now the efficiency and drag and drop it into the data point field of the efficiency node. The same I do for the flow rate, drag and drop. And the same for the power, drag and drop. And the same for the speed, drag and drop. As you can see, with this short example, I created now a complete new plant structure to structure my data from my my data object, pump1, with those tags flow rate, power, speed and efficiency according to a plant view, which represents a structure of my plant. Same you can do, for instance, in a UNS, in a unified namespace way. in a short way. For the other pumps, I do it accordingly like I did for the first pump. I also can do an import and export with a mass engineering. Also that I can show you in some later videos. Now I will show you how you can store your data. For that, just open once more the Para tool. Remember the icon in the Getty with a red line, Para. In the Para, browse to the pump objects which we created already with those tags. I will show you the example for pump 1. For the other pumps, you do it accordingly how I show it to you here, or you use the mass engineering way, which I will also show in some later videos. I would like to store the tags, the values, flow rate, power, speed, and efficiency. For that, I will just go to the flow rate, and I will insert another configuration here, which is called Archive Settings. On the Archive Settings, just choose the right archive group and activate. And say OK. The same I do for the power. Insert the archive. Choosing the archive group, activating OK. The same I do for the speed and for the efficiency. Archive. Activate. OK. And for efficiency as well. Archive. Activate. OK. It's also suggested to create additionally archive groups for your tags, which changes accordingly in a different speed, fast, mid, and slow in your project. I just placed them here to demonstrate quickly in the event group. That was quickly to show you how you can store your data. Now the values of my pump is stored in my archive, in my Postgre database. I have already shown to you how you can connect to the data with our OPC UA Client connector. I have shown to you how you can structure the data with our plant model editor to bring it in a plant view. I have shown to you how you store the data. And now I will show you how you can publish the data. In WinCC OA we have several connectors. I will show you now how you can publish the data northbound wise with our MQTT Publisher. This publisher allows you to post topics into an MQTT broker. I have running on my host a Mosquito broker. This you can download for free. Let me show you. First, we need to start from Getty, again, the plant model editor. Just open that. Remember in the plant model editor, we did our plant view with the My Plant 1, Area 1, with the Line 1, the Pump 1, and those tags. We structured it like this. Now I would like to post this view into my broker. For that, just pick the MQTT on top, select the system, and on the right side you can find your views. You can have multiple views created, but just one view can be assigned to the publisher. But you can also start multiple publishers. Take the view, just drag and drop the view onto the publisher. Drag and drop. Now you can see my view is assigned to the publisher. Now I still need to decide which will be later the permissions in the view. When I connect with the MQTT client to my broker, what is then allowed? For that, I have to give permissions for those nodes in my view. For instance, you stand on area 1 node, and that can be a permission only for this node or for subnodes. You can apply it only for this node or for this node and subnodes. I will choose for this node and subnodes, and I will assign read permissions. Close. Yes. Now I need the connector, the publisher started, that allows me to post this topic into my broker. For that, we have to go to the console and append a new manager. This is our connector. When you browse in the list for the MQTT Publisher, just pick that and assign a unique number, for instance, -num1. Because you can start also multiple publishers and say OK. After the publisher started, now we finally need to post this topic via the publisher into the broker. For that, again, you go back to the Getty and open the system management with the wheel icon. From the system management, you go to the driver, into the MQTT Publisher. In here, we just need to establish the connection. We have to give the host name and the port. In my case, it's on localhost running, so therefore localhost. And the port is always 1883 as default. Username, password we don't need. Just one more suggestion before we activate that. Go to the Advanced tab and keep an alive interval, for instance, 1 second. Check the broker connection. And if you want to make your topic retaining in the broker, just go to the Default tab and mark it as retain. That means that when you disconnect and reconnect to your broker, that your view is still published. After you did so, just say apply. You can see we already got the connection to the publisher. And to publish now finally our view into the broker, we just need to run the command here to publish. You want to execute? Yes. Okay. Now my view was published into the broker. To prove this, you can use now a tool like, for instance, the MQTT Explorer, which you can also download for free, to check your topics. I have this MQTT Explorer already downloaded, and I will switch here to this tool. The tool comes up like that. You just need to create a connection. Just add the connection, just give a connection name. I just call it here WinCC OA. Keep the protocol on MQTT, and you just need to say the host name and the port. In this case, the same, local host with the port 1883. Username, password not required. One suggestion in the Advanced tab, remove the sys topic just to keep the topic with a hashtag that allows you to browse all topics in the broker. Go back to back, save your connection and try to connect. Now you can see my topic was already posted. I have my plant 1 with area 1, with line 1, pump 1, and I have the flow rate, power, speed, efficiency values changing. That was quickly how you can publish your data northbound wise with our MQTT Publisher. In this video, you have seen how you can connect to your data southbound wise, for instance, with our OPC UA Client. I've shown to you how you can structure your data afterwards to get it in a plant view, for instance, like a unified namespace, how you store your data in WinCC OA to archive it, and how you can publish it northbound wise with, for instance, our MQTT Publisher. as a connector. If you want to learn more about the WinCC OA world, go to winccoa.com/explore and join our community group and follow us on YouTube. Thank you. See you next time.